Okay, so we're going to start today with properties, and then we're going to do a little bit with piecewise graphs and absolute value limits. All right, so first off, properties of limits, the ones that we're going to focus on are pretty easy. Okay, so don't try to look at this and make it any harder than it really is. If I say the limit as x approaches a of 4 times f of x, well, I've got the limit as x approaches a of f of x is 3, so 4 times 3, 12. That's all that it means, okay? So it's as easy as it looks. I know the notation right here looks like it's going to be confusing, but it's not. It's just 4 times whatever we got for the limit of f of x. So easy. This one, you just do f of x times g of x. So the limit here was 3, the limit here was 2, so it's 6. This is the square root of g of x. Well, the limit was 2, so it's just square root of 2. All right. If you ever are filling out a class kick and it has one where you have to try to get the right answer, anytime it's a square root, I just write root and then the number. So it would be put like that into class kick if you were doing it on like your homework. So you have to write out the word root. All right, this one right here. So you're going to go 2 times f of x. So that's just 6. G of x is 2. We do have to substitute whatever's right here. Remember, when you're finding a limit, you plug it in for x. So you have to put an a right there. Don't leave it as an x. So it's just 4 minus 5a. Okay, so these are super easy. Questions on any of those? No good? All right, then we're going to practice some more of these piecewise graphs without having to see the graph. Okay, we did a little bit of this the other day. We talked about it. If you don't have a graph in front of you, and I ask you the limit as x approaches, this is 1 with a minus. Do y'all remember what 1 with a minus means? What side of the graph is that? It means coming towards it from the left. And 1, this one is supposed to be a plus. It looks like a minus on mine. That's a plus. We're going to say from the right. Do I have these in the correct order? Can y'all tell on yours? Does it say minus plus? Or is it too little to see? It's correct. Okay, I just didn't want to do it backwards and be confusing. All right, so from the left, then we have to look up here. Which side of 1 is x's that are less than 1? Would that be the left side of 1 on a number line or the right side of 1? So when x is less than 1, that really means the left. X is greater than 1 means the right. So always identify that when you start, and then it makes it easy. So if I want to know the limit as x approaches 1 from the left, I want to plug 1 in to the left side of 1. So I plug 1 in right here, I get 0. This 1 from the right, I need to plug 1 into this equation because this is the equation for everything on the right side of 1. So if I plug in 1 right there, I get negative 1 squared, which is positive 1. Negative 1 plus 1 is 0. Did everybody follow the math on that one? Any questions, just stop me. So when these two match each other, what does that mean for this? The limit as x approaches 1. It matches, so we can use it. If they don't match, then the limit doesn't exist. When you have a question like this, the limit as x approaches 3, if it's not the place where the graph breaks apart, then we can just plug it in only to the one that occurs at 3. So which one of these two equations, would we want the left or the right side of 1? Because 3 falls in this domain right here, so I just plug in 3 right here. It is also 0. It just happens to be 0. Now, one thing I want to point out, if I had given you this right here and I didn't ask these two questions first, would y'all have all known that you've got to check both sides? Okay? If I give you this and I say, what's the limit as x approaches 1? You've got to check the left side and the right side of 1 and make sure they're both going to 0. Okay, so don't forget about that, right? Because it won't always ask you this question before it asks you that question. All right, so let's come over to here. X is less than 0. Is that the right or the left? Okay, if you're having trouble at all understanding this, let me know. X is greater than or equal to 0 means the right. 0 from the left, that means I need to plug 0 in to this top one. What is e to the 0 equal? So I don't want you to put an answer like that. If you can simplify e to the 0 and make it 1, go ahead and make it 1. 3 is the answer I would be looking for. Now, what if you got e to the first? Could you simplify that? I would rather, if you get e to the first, just leave it as e, okay? The only one that we know the answer to for e to the anything is e to the 0. Change that to 1. All right, this is a plus down here. So 0 from the right, we plug 0 in right here, we get -5. So does the limit exist? They don't match because these two are not equal. And the limit as x approaches -2. Which one do you need to plug it into? Only, ooh, is it the bottom? Where's -2 compared to 0? Be the top. So we would get e to the -2 plus 2, or 1 over e squared plus 2. Either one of these would be okay. If they don't say you can't have negative exponents, then I don't care if you put a negative exponent, but these are equal to each other. And that's as simplified as you get. Okay, y'all good? All right. So down here at the bottom, we've got to do some absolute value things. Let's just think about the graph right here. Do y'all remember what the graph of absolute value of x looks like? What shape is that? That's the V, right? So it goes like this. So looking at that graph right there, what's happening as we go to 0 from the left? Where's it headed? To 0. What's happening as we go to 0 from the right side? To 0. So what's the limit as x approaches 0? 0. That's pretty easy. Do y'all remember what the graph of x minus 2 in absolute value looks like? Which way does that shift? Remember, when you have it inside the function, it moves left and right, correct? If it was out here, like x minus 2 out here, that moves up and down, okay? So this is going to shift to the right too, and it still makes its normal absolute value graph. So now they ask the question, as x approaches 2, that's a plus. So 2 from the right, it's still headed to 0. 2 from the left is still headed to 0. So our limit is 0. What if I had asked you the limit as x approaches like 5? What would you do? Would it be easier to look at the graph or to look at the equation? Just plug in 5. So what's the answer? 3. What if it was x approaches -5? What would the answer be? Would it be 3? Because -5 minus 2 is -7, but remember it's in the absolute value, so it would actually be 7. Okay, so just be careful. So that's just regular absolute value. This third example over here, this is whenever you have absolute value either in the numerator or the denominator. Okay, I want you to think about this one. Let's say that I plugged in a number on the right side of 2, a number bigger than 2. So we could go 3 or 50 or 1 billion. Is the top going to turn out positive or negative? The top would be positive. Does that make sense? What's the bottom going to be if I plug in 3, 4, 5, 100? See how your answer would be positive, right? Let's say I plugged in 3 on the top, 3 on the bottom. What would my answer be? It's positive what? 1. Does everybody get that? So the right side of 2, I would get positive 1. But now let's think about plugging in a number smaller than 2. What if I plugged in 0? What would I get on the top? If I plug 0 in right here, I would get positive 2, correct? What if I plugged in 0 to the bottom? You see how you would get positive 2 over -2? What if I plugged in -50 to the top? What would I get if I plugged in -50 right here? I would get positive 52. What if I plug in -50 right there? What do both of these things reduce to? Okay, so whenever you have absolute value as part of your fraction, on whatever number you have right here, that's going to be kind of like the breaking point. Anything greater than this number is going to be a positive 1. Anything smaller than that number is going to be a -1. You will probably see a question like this on your test. So just be prepared. You're going to see that. You've got to understand what to do with absolute value as a fraction. Because whenever you put negative numbers into absolute value, they turn positive, but they'll still be negative on the bottom. So it's going to end up being +1 or -1. The graph of this right here, if you were to graph this thing, everything smaller than -2 is -1, and everything greater than -2 is +1. Does the limit exist as we approach 2? No. Now, does the limit exist as we approach 3? What would the limit be as x approaches 3 in this problem? We plug in 3. Look where 3 would be over here. Is it the same on both sides? Yeah. So the only place it doesn't exist is at 2. Everywhere up here, the limit's going to be 1, and everything down here, the limit's -1. So don't think the answer is always does not exist. You have to make sure I'm asking you the question at the breaking point, okay? All right, if you turn the page, I think, does it say independent practice and stuff like that? Is that what it says next? Yes? Okay, so that's actually the homework, but we're not going to do it there. There's a class kit called homework. Before we go over to the homework, though, I want you to look through some of those in the class kit. Are there any that you see on those, like, independent practice that you wouldn't know how to do? Do y'all remember from last class, if you have something like a fraction, I'm not going to do this problem. I'm just showing you for example. What do we do in a problem like this? Can I plug 0 in? So this is the one where you have to go through and you have to get a common denominator. So you're going to get more practice with that today, okay? What if this right here, let's say it had been an 8. Would I have to go through this process? If you can plug this number in and not get 0 on the bottom, then you just plug it in. But if you plug it in and you get 0 on the bottom, you've got to do the thing where we cross multiply and get a common denominator. So you'll have some of those. The other kind you're going to see were the ones where you had something like this. I don't know if that's exactly what you might see. Something similar to that. Think about what you would have to do. Hello? Okay. Caden? Lowenstein, are you? Yes, I do. Okay. Okay, I'll send him. Caden, you need to go down to the, you're supposed to, yes, but I think you'll be back in a second. Okay, so what do we do in a problem like this? How do we fix it to where we can't get a 0 on the bottom? Do you remember? You multiply by something.
Square root x plus 4 minus 4.
Yep, remember, this is the one where you change the sign in the middle. You do that to the top and the bottom. Once you distribute all this out, things are going to cancel to where you can then plug in 0. One thing that might happen on one of your homework problems, if after you've done all of that, you still get a 0 on the bottom, your answer does not exist, okay? You try to do all this and see if it works. If it still doesn't work, it does not exist, okay? And don't forget the other, this was called Rationalize the Numerator. And then the third thing that we try when we can't substitute is to factor, okay? So today's homework has a mix of review of this stuff, and it's got some of the properties and the absolute values that we did today, okay? And then it's got a graph where you read limits off a graph. So it's kind of like a review. So the homework's fairly long today, so I'm gonna give y'all time now to work on it.